how to print and peak pick a carbon NMR spectra for the Donahue Research Group and the PIGSA Research Group. When you go to Topspin and open up the appropriate notebook numbers folder, you will see that once characterized, you will have a list of possible choices. The carbon NMR spectra are in this case 21, 22, and 23. The first carbon spectra you'll open up is going to be the one that ends in 1, and it'll read ZG-PG30. So double click that folder and then double click the actual name of the spectra. You can see that once again Topspin has tried to peak pick and integrate for us, but that is its first mistake. You do not integrate carbon spectrum. So we will be getting rid of all of these integration points by clicking that interactive integration button that looks like a staircase, clicking this bracket with all the green inside right here, and then clicking delete and hitting OK. You will then save and return to the normal spectrum. You can see that you will have a nice large solvent signal smack in the middle of the spectrum in this case. We do not want these peaks picked, and also if you zoom in and look, it has once again picked all the little tiny peaks on baseline. But if you zoom out, you can tell that those peaks aren't actually significant. So we go into manual peak picking, and we just hit delete all. It is automatically in that mode, so you can click and drag and peak pick. It does not matter that each of these peaks isn't in its own little box. It only calls the numbers. It does not determine anything else relating to them. We have this nice triplet here that belongs to deuterochloroform, so we're going to slide right by it. Click and drag. Again, make sure to leave plenty of room between the top of the peak and the top of the box so that you're sure you got it. Click and drag. Zoom out using the magnifying glass with the minus sign. Make sure you got everything, and then hit this floppy disk with the downward arrow. You will then go to the DEPT 90. So this is DEPT SP 90, and it'll end in the number 3. Double click, and you can see again it has tried to integrate and peak pick incorrectly. So we integrate, select all, delete all, OK, save. So here you can once again see that it has tried to pick even these really tiny peaks. No. DEPT 90 only shows CH peaks. It does not show CH2s, and it does not show CH3s. So only CH peaks will show up. So you can peak pick, select that, delete that box, just drag and drag to get the boxes selected. If you do see some really tiny peaks that don't quite make sense with the number of CHs you should have in your spectrum, it is possible to have bleed over from the other signals, which is possibly what these little ones are. Do not pick them, only pick the ones that are CHs. The bleed over peaks will be significantly smaller than the actual peaks belonging to CHs. So you can hit save and return. Next one you'll look at is the DEPT 135. So it ends in, the number will end in a 2, and then read DEPT SP 135. Double click, and you can see it really went ham trying to integrate these peaks. We're going to delete all of Topspin's hard work by going into integration, select all, delete all, OK. Save and return. By using this arrow that's double-headed right here, you can pull it up so that you can see you have peaks that are both pointing upwards and pointing downwards. The peaks that are pointing downwards are CH2s. Peaks pointing upwards are CH3s and CHs. Just a little reminder for when you look at this, odds are up, evens are down. If it has an odd number of protons, the peak should be pointing upwards in the depth 135 and downwards if it has an even number. If for some reason it does not have that correct, so if for some reason you look in this region where the benzene peaks are and you see that they're pointing downwards instead of upwards, you will go to this interactive phase correction icon right here, this little of a heartbeat, and click it. You will then click this 180. What this does is it flips the spectrum upside down to correct it. Ours was correct to begin with because we had the benzylic CHs pointing upwards, so we can just save and return. Again, you can see it's tried to pick these little tiny peaks. We don't want them. So we will enter peak picking integration mode, delete, click and drag. To select the CH2s, you do not click and drag down here. What you do is you look at the peak and you estimate how tall it should be if it were to point upwards. From there, you click and drag to make sure that that region is selected. So if you can see, if I just clicked here, it doesn't call any peaks. If you accidentally make a box where you didn't want one, you right click and hit delete region under cursor. So here we can click and drag, and you can see that it called all 4 peaks despite these 3 being pointing downwards. It's because if this peak was pointing upwards, we would have called the top of it. Here's the last one. We hit save and return. From here, you will go to the print bar. Make sure that print with layout, start plot editor, and use plot limits as saved in plot editor is both selected. And from here, you will scroll until you find the 13C_MGD template and hit OK. This will then pull up the plot editor, which you were introduced to in the Proton NMR video. And you will see that it has 3 little text boxes labeled 13C spectrum, depth 135, and depth 90. If you slide your mouse along without clicking, you will see that there's a box here, a box here, and a box here for each spectrum. To get the other 2 spectrum to appear, what you will do is click the large box, so this one, you can see it outlined dashed in red, and hit edit. Not 1D, 2D edit, just edit. And then click the dataset tab and hit select. You will click just once the name that appears and then hit edit. This will automatically pull you into the correct folder where it's displayed, and you will then double click 21 and double click 23 and hit apply. When you are taken back to this, you will make sure that the one ending in 1 is selected, hit apply and OK, apply and OK. You can see that when you hit apply, this first spectrum appeared, and when you hit OK, it then populated the depth 90 spectrum as well. Looking at these peaks, we can see that they are horribly, horribly small and not at all useful for actually looking at them. So what you will do is click to make sure you've got that green box, those green boxes still showing, 1D, 2D edit, and pull upwards using this double-headed arrow. There. You will also notice that there's a lot of space between this blue scale and the actual baseline. So you use this double-headed arrow that has the bar connecting the 2 heads to pull it downwards. You still want to be able to see that bit of static at the bottom of the baseline. You'll then hit close. You want these peaks to be tall enough that they're easily seen, but not so tall that they touch the baseline or the peaks from the DEPT 135. The DEPT 135 is also really tiny, so we will go 1D, 2D edit, pull it upwards. For the DEPT 135 and the DEPT 90, you do not use this slide tool. You do not click either of these arrows over here, or any of these for that matter. The only arrows that you should be using is right here. You can then hit close, go to the DEPT 90, 1D, 2D edit, and again, you should only be using this one to increase the scale. You should not be using any of the other 4 icons in that row, just this one right here. Hit close, then File, Export, and you will save it as the notebook number, space 13C, and hit Save, and hit OK, and you are now free to print your spectra and begin in labeling the peaks.